Now I'm going to show you three important rules of differentiation, namely change rule, product rule, and the quotient rule. So first, I would like to introduce to you the chain rule. So far, you have already learned how to differentiate the expressions such as the quadratic function or maybe even the cubic function. But before you can differentiate, you need to do the expansion first before you can apply the differentiation formula. So this method is a bit tedious. And some more, if you are going to differentiate this to the power of 12, it will take even longer time and more tedious and efficient to do the differentiation. So this is why we are going to introduce you the chain rule. Because chain rule is a more efficient way to do it. So let's say, for example, we want to find the differentiation of 2x minus 3 to the power of 12. What we can do is, first step, you have to do that. You let y equal to 2x minus 3 to the power of 12. And then we aim to find the dy dx. So because we actually let this thing to be the y, so we are trying to find the dy dx. Then we can find the differentiation of the 2x minus 3 to the power of 12. So next, we're going to let u equal to 2x minus 3 without the power. So then that means, right, we were having y is equal to u to power 12. So by how to find the differentiation of the 2x minus 3 to power 12, we will then to find the dy dx. So we can get it. Yeah, get what I mean, no? So we can apply the chain rule. How the chain rule works, right, is actually applying this formula. They actually utilize the u, in this case, as the intermediate variable to help you to find the dy dx. So you can see from the formula here, we actually having we have the dy du and the du dx. So the multiplication of these two terms will give you the dy dx. So dy, yeah, so it looks like, but it's not true. It looks like actually you are doing the dy du times du dx is because you can then cancel the du. So it will become like the dy over dx, but it's not true, but it looks like it is doing this way. Yeah. But so you can actually thinking that you are actually getting dy over du times du over dx is because the du can be cancelled and then you can get the dy dx. But in fact, it's not true though. But you can think it this way, easier for you to understand the chain rule. So, okay. So since we're actually having, so what I'm going to do to find the du dy, dy over du, since we're now having the y is equal to u to power of 12, we can first differentiate the dy over du. And we will then get the differentiation. So we can bring down the power 12 and the power 12 power become 11 now because minus 1. So you get 12u to power 11. And then you can replace now the u by the 2x minus 3. So this is, you get the dy over du in terms of x. Next, we're trying to find the du over dx. So remember, we have let u equal to 2x minus 3 earlier. So we can differentiate the du over dx. Differentiation of 2x is equal to 2 because differentiation of x is equal to 1. So 2 times 1 is 2. So minus 3, differentiation of the constant is equal to 0. That's why you get the 2 here. So after you get it, next, you can then substitute into the formula, the chain rule formula. We having the dy over du is equal to this, and then multiply the du dx. So we can get our final answer. So this is what we mentioned about the chain rule. So it's much easier than you do the extension to find the dy dx. However, I'm going to show you another easier method. Instead of getting the u, we can get it more with an easier way. So let's look at the method here. So same example I'm going to use, which is a 2x minus 3 to the power of 12. So we are going to differentiate it from the outermost to the innermost. Step 1, okay, you will differentiate the power 12 first. So you can see I label it in red. So let's differentiate the power 12 first. So I bring down the power 12 and I minus the power by 1. So this is a step 1. Step 2, I'm going to differentiate the content, which is the 2x minus 3. So I will now get the differentiation of 2x minus 3 will be equal to 2. Remember? So differentiation of x is equal to 1. So 2x, it will be 2. And minus 3 is constant. So the differentiation of constant is 0. So that's why you get only 2. Then you simplify, you get the final answer. So this is much easier. This is easier and faster than the previous method. Yeah. So I will advise you to use this method instead of letting you eat. Okay, next I'm going to show you the product rule. As the name implies, product rule means the multiplication of two functions. So what you do is to keep u and you differentiate the v, plus you keep the v and you differentiate the u. So it will be keep differentiate plus keep differentiate. Okay, so let me show you using the example here. Example 2 here, we have a two function. So this is example the u and this is example the v. So we're going to use the differentiation by keep u differentiate v plus keep v differentiate the u. So, okay, so step 1, I'm going to keep the x. Step 2, I'm going to differentiate the v. Okay, but the differentiation of v in this case, right, will be a bit complicated. So I will show you separately about the differentiation of the v first at one side. So you see differentiation of this. So in fact, if you look at this is a function with a high power 5 here. So we can actually differentiate it by chain rule. So what we will do is, first step, remember, bring down the power. And then differentiate the content. The differentiation of the content will be 2. You keep the 2 here. And you differentiate, you bring down the power. And you minus 1 on the power. And the differentiation of the constant is 0. Yeah. So this is what you will get. And then I write it here already. I wrote it here already. So yeah. So next, I go into, after I have already keep differentiate, I'm going to keep the second term, and then I differentiate the first term. Differentiation of x is equal to 1. So I just write 1 here. So can you see that? Okay, next, I will then simplify it. So you can see I have these 2 as my common factor, but the power is not the same. This is 5 minus 1 and this is 5. Okay, so but I'm going to take out the lowest power. Okay, this is a rule. Take out lowest power. Why I said it's a rule, right? It's because easier for you to simplify the algebra expression later on. So take out the lowest power. So you see, let's say I take out the lowest power, which is 5 minus 1. So my leftover here will become, even think about it. So since I take out the 5 minus 1, this one, there's nothing left. But this one is a 5. So since I take out the 5 already here, but there's a negative 1, I also took it out. So I will have to put back a 1 here in order to balance, because minus 1 plus 1 equal to 0. Bear in mind the inverse law. So let me show you an example what it means. So since we're actually having, for example, let's say you're having 5 to the power of n minus 1 here, plus another one you have is x to the power n. So you're going to take out the lowest power, this. So then you will have 1 here plus x to the power of 1. Because think about it, when you do the expansion, you will, this one, we will get this. And then when this one multiply this one, you will get x to the power n minus 1 plus 1. So then you will get back what you want. So this is actually how it works. Sorry, yeah. So that's why since you took out negative 1, you are going to add back the 1 here. So more and more example, more and more question when you do, right, you realize that you encounter scenario like this. It's always like the difference of the power is by 1. So take out the lowest power and the highest power, we left with a power 1 inside the bracket. Okay, so take note of it. So I'm going, yeah. So then after which you will get the final answer, simplify it to get this answer. Okay, So bear in mind, take out always the lowest power when you want to simplify the expression. Okay, next I'm going to show the quotient rule. So you can see the quotient rule here is actually a fraction. It's a division of two functions. So what it do is that you will get the v squared, which is the denominator, you square it, you keep the v and you differentiate the u. Minus okay, so these are a little bit similar to the product rule if you pay attention to it. So this is our product rule. Okay, it looks very similar to this quotient rule we have here. Except what? Except the sign in between. For the quotient rule, right, the sign in between must be a negative sign. So you can see here, so it must be, you keep the v, you differentiate the u, then you minus, you keep the u, and then you differentiate the v here. Okay, so this is quotient rule. So quotient rule will apply it when you're having a division of two functions. Okay, let me show you an example here then. So we have an example D here, x squared plus 7 divided by square root 2x plus 1. So this is to keep the v, differentiate the u, minus, you keep the u and you differentiate the v, and then divided by the square of the denominator, which is the v squared. Okay, so just use an example to see it. So you square the denominator, okay? This is a denominator, you square it. Next, you at the numerator, you keep the denominator and you differentiate the x squared plus 7. So differentiation of x squared plus 7 is 2x. Okay, so next, I'm going to differentiate the square root of the 2x plus 1. So pay attention to it. I will then differentiate it separately also because it's a bit complicated at the moment for you. So differentiation of this, you must convert it to the index form first. So similar chain rule. Step 1, we're going to differentiate from outermost to the innermost. So we're going to differentiate the power. You bring down the power half here, and you minus the power by 1. Next, you're going to differentiate the inner small, which is the content here. You will then, differentiation of 2x plus 1 is 2. So this is what you will get for the differentiation. So you see, I have also write it here already. I've already wrote it here. So yeah, so this is a differentiation of the denominator. Then next I will keep the numerator. Yeah. So this is how it works. So okay, you can then see now the differentiation, but then now we are going to simplify it. The square of the denominator get you the 2x plus 1. Okay, then then we are going to take out the common factor at the numerator here. You see we're having half here and the other one is a half minus 1. So remember earlier I mentioned to you, bring out the lowest power. And then here you add back the 1 here because you bring out the extra negative 1 here. Okay, then now of it. This is the important part about how you simplify the algebra in this chapter. So since you take out the additional negative 1 outside, you're going to add the 1 back in the bracket. Okay, so then now going to do the simplification, you will get this. Then if you pay attention, then now these two are the same thing. So the power negative half, you can actually bring it down and you can add to the power 1 here. It become 1 plus half, it becomes 3 over 2. So this is how it works. So I just want to show you what it means. So this is actually applying the law of indices. So you can see the negative power actually means 1 over 2x plus 1 to the power half. Okay, multiply then what we have here is the 4x squared plus 2x minus x squared minus 7, then divided by this 2x plus 1. So that's why you will get the half here plus the 1 power 1 here. So that's why you get the 3 over 2 here. So this is how you get it. Okay. Yeah. So next, this example, I'm going to show you that there's a lot of people, right, will mistaken that this question, example E here, a lot of people thought that they have to apply the quotient rule. But in fact, you shall not apply the quotient rule. Because why? Quotient rule, right, you take note, you will apply it when you're having u divided by v. What does the u and v show? They are the function of x. So you will actually having the function of x. Then only, that means, right, you have two function, the two, how to say, you're actually having one function divided by the other function, then only you will actually apply the quotient rule. Meaning, we'll say, like, example here. So both numerator and denominator contain the x, only you will apply the quotient rule. But in this case, right, you realize that this is just a number. So we are not going to apply it's just a constant, So we are not going to apply the quotient rule. Instead, right, all we need to do, we can take a look at what I do. I convert the third form into the index form. So it becomes the power of negative half here. Then I'm going to apply the chain rule. I bring down the power. So the 7, I leave it here. I bring down the power and minus the power by 1, and then I differentiate the content, become a 2 here. Then I simplify it to get this. Then the final step, I convert it into the surds. And this is how I get it. So let me illustrate more about how I convert the index form into the surds. So because of the power is negative, I can remove the power negative by actually bring it to the denominator here. And next, I'm going to convert to the surd. So since it's a power 3 and this is a square root, I can bring out the 1 to x plus 1 here and left with 1 to x plus 1 in the square root. So this is how I get the answer. Okay, so this is how, so take note that this one we are not going to apply the quotient rule because the numerator is a constant.